Here in the next example, we have that the width of Hagrid's rectangular garden is 3 yards less than its length, and we also are given that the perimeter of the garden is 58 yards in total. We're asked to determine what is the area of Hagrid's garden. So, of course, if we're asked to determine the area of the garden, we want to know kind of what shape we're dealing with. It does say it's a rectangular garden, and so with any rectangle, if we multiply the length times the height, that's of course going to give us the area. So to help us figure that out, we're going to have to multiply the length times the width. Now, I don't think we have any exact length or width measurements right now, so we're going to have to be able to kind of do some manipulating here to be able to solve for all of that. So we do have the fact that the width of the garden is 3 yards less than its length. So if we use W, let's define some variables. So W is going to represent the width of the garden, and L will represent the length of the garden. So the width is 3 less than its length, right? So the width is 3 smaller than the length. So that means that we would have to take the length and make it smaller by 3, and then that would make it the same as the width. So in other words, that would say that the width is taking the length and subtracting 3 from it. So we have that true statement involving W and L. We need some more to solve for unique values of L and W. So we also know the perimeter of the garden. So by perimeter, of course, the perimeter is going to be the total distance all the way around. So if we circled all the way around, it ends up totaling 58. And so circling all the way around, of course, is going to involve a width and a length and a width and a length. So really, traversing 2 lengths and 2 widths, adding that all together is going to equal the perimeter, which is equal to 58. And so based on those 2 equations right there, we can put them together in a linear system, and then we should be able to solve for a unique value for W and L here. So it looks like it's ready to do some substitution, because what we see here is we've got the W is isolated. So if we take L minus 3, we can substitute that in for W into the other equation. So if we do so, then we'll have 58 equals twice L plus twice of the quantity of L minus 3. And then if we do some distribution, 2L will combine with the other 2L to be 4L. And then minus 6. If we add 6, 64 equals 4L, and then divide both sides by 4, that's going to give us that 16 should be the length. And then if we've got that, then we should be able to plug that in somewhere to find W. So if you just plugged in 16 right there, 16 minus 3 is 13, which equals W. So then we should also know that the width of the garden would be 13. So I think these lengths should all be in yards, yep, because everything was given in yards. So really we should kind of be more specific in giving these labels 16 yards and 13 yards. Perfect. And that should all make sense when you plug it into the other equation as well. You'll get a perimeter of 58 from those measurements. And so to kind of finally finish this problem, it's asking for what the area of the garden is. So to get the area, then we're going to have to take 16 yards and multiply it with 13 yards then. So of course you're going to get units that are in square yards, since we're dealing with area, and 16 times 13 is going to yield us 208.